Hello. I'm just bored with a video. That's the right light? Yeah, that's the right light. Okay. I was doing a bit of clear out under my stairs and I came across this, and I forgot that a couple of months ago I was going to do a video on this and then forgot. MPS power supply. Well, a very typical problem. It's got one rail that works and one doesn't. Originally I was given this dead. I put a temporary power cable on it. But yeah. So power it up. I'll open this door a wee bit because this isn't proven yet, but power it up. And we've got 5-volt rail there. Okay? And if I switch it back off, you can tell it's got good capacitors on it, that's for sure. If I switch this back off and I go here, we spark. Capacitors are quite charged there as well. Switch on. We've got 0.7 volt. Should be 12 volt, that's a 12 volt rail. We've got 0.7. Okay. So, what's going on there? Well, it should actually be quite an easy fix. Show you why. I've got a MPS 2 master manual here. I couldn't even quite this nice little folder that I got for friend, but I got the schematic for the power supply here. It says in technical description back here that the 12 volt supply is derived off the TR1, and sure enough it is. All it does is it comes through the rectifier, through a transistor which is controlled by a regulator chip, and out. We're only seeing, about 700 0.7 volts, 700 millivolts. It kinda paints a picture for you. I'll show you why. If this thing will ever be bothered to focus. Maybe it'd be better doing it under its own lights. Turn that back off now. Yeah, it works better under its own lights. Come into focus. There we are. Okay. You need about 0.6, 0.7 volts to turn a transistor on. Okay. And we're seeing that here now. Transistor essentially is two diodes. One's pointing that way, and one's pointing that way. For an NPN anyway. The fact that I'm seeing 0.6, 0.7 volts here, I think that the collector on this transistor is open, which effectively means the supply coming in for the rectifier is missing, and that 0.6 I'm seeing is coming through the remaining diode in the transistor there. Because that would make sense that if this end was completely open, actually it could be just the 0.6 flowing through that resistor there as well, but you expect that to be. If this was shorted, you'd get over 20 volts on that line. The transistor would just be a wire, and there's about 18, 19 volts coming through here. Quite up. And it can be held for quite a long time under that capacitor there, that reservoir capacitor C15. If it was completely open, I'd probably expect to see nothing, because there would be, it'd just be like this would be missing. I don't think I would see the full 0.6 volts coming through here. If this wasn't working, I wouldn't expect to see anything there either. I definitely think that transistor's open, and I'm just seeing the 0.6 flowing through one leg of it, or flowing through this here. But I'll determine that in a minute. Right, so I've got a part, and I've just tested it, and I think I've confirmed my theory. I've got 20 volts coming in and nothing going out. Now, to test these things, you've got to take them in bits, so I'm not going to show you the test results on camera because I don't want to kill myself, but it's too much fiddling, unfortunately. But what I found, yep, okay, I've got 20 volts coming into the collector, clear as day. I've got a 0.7 volt source coming up to the base. I've got solid all coming out the emitter. I've only got 0.7 here at the emitter, so that transistor's dead. So, just so happens I've got another one somewhere. Yeah, I've got a packet of them somewhere. Should be knocking about, not a million miles away. I'll find them in a minuet, but I'm going to change that transistor out that's poking in there. I've got plenty of those regulator chips as well. I might change that as too. I'll test this pot as well, but I think the pot's okay. I've got a solid voltage going out. I've just got nothing. Solid voltage going out for that chip, but I've got nothing coming from the transistor. I've just got 0.7. So I'm more certain than ever that 0.7 that I'm seeing the emitter there is just the base signal for this. It's just passing through the diode section of the transistor now, or bleeding through this resistor. So yeah, we'll change it out and see how we go on. The proper way to take these off is they're a bit tricky. It's soldered underneath. So a simple way to take them off, you don't take the transistor off the heatsink. Take the heatsink screws out, then desolder it off and take the whole thing off the unit. Right, so there you go. Actually not a transistor at all. It was a regulator chip. An MC 1723. That's that repaired. So I'll button it all together and I'll test it in something. So it was this, just to recap, it was this thing here. It didn't look damaged. It clearly wasn't working. I've got a ton of them sitting in the bag. Anyway, I was kind of half right with my diagnosis. With this being dead, now the camera decides not to focus. Come on, that's better. Bizarrely, the closer you get, the better it works. With this thing being dead, probably getting maybe the wrong signal there. I mean, I was measuring 0.7 all the time, but maybe that was the pass through from here to here. Bit of leakage, or leakage from here. What we're getting is no drive signal going to the transistor, although it looked like there was. That's why sometimes testing stuff can be a bit tricky. I prefer digital electronics any day. Analog electronics have always perplexed me. So this transistor wasn't getting turned on properly, and all we were getting was 0.7 through there. Transistor might have been good, but not getting turned on, it might as well have been open circuit. So whatever was coming through here was just bleeding through here and going out. Change that chip. Good. Yeah, I see too. New one in there. That's actually a better part as well. That's a ceramic one, it'll handle heat better. Change that. All of a sudden, 12.22 volts going through there. I'll probably need to regulate that down a wee bit. 12.2, not too terrible. I'll probably turn it down slightly to maybe, I don't know, just over 12 or just under 12. We'll get it set up. But now that's been replaced, that's working, and my 12 volt line's back. So I'll get it buttoned up. I'll set that voltage properly first. And yeah, I'll get it buttoned up and see what we're doing. I mean, actually, I might not touch it at first because 12.2, when the board starts to load it down, that 12.2 is maybe going to drop a bit. Yeah, I'll put this back together and we'll see how it goes. There we go. All buttoned up, back together, all working. Right, next. And by the way, if you wonder about the capacitors and where they're going up, it's been 10 seconds since I turned it off. Yeah, it's quite a lead off time with that, that's good capacitors. And move it down to the 5. You see? 5 maybe not as good. Still a good 5 volt on that capacitor, not in the 12 volt line. But yeah, that's all working. All's good.